Today we are going to discuss and explain Pythagorean theorem geometrically, which states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the another two sides. In fact, Pythagoras theorem is considered to be the first great theorem of mathematics. So let's do it. If I write an equation x plus y is equal to z, can you give me some solutions for this? Obviously, 1 plus 2 is equal to 3, or 2 plus 2 that's equal to 4. In fact, there are infinitely many solutions to this equation x plus y is equal to z. Let's make it little complicated. If I write x square plus y square is equal to z square, and I ask you give me some solutions for this equation, obviously 3 square plus 4 square is equal to 5 square, or 6 square plus 8 square is equal to 10 square. In fact, there are infinitely many solutions to this equation. But what does this equation represent? It is actually a Pythagoras theorem, which states that in any right angle triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. That means if we take any right angle triangle, let me draw a right angle triangle. If these are the sides, then x square plus y square is equal to z square. There are many ways by which we can prove Pythagoras theorem geometrically. Today I am going to show you one method. Let's take any arbitrary line, and I take an arbitrary point here. Let's take this as x and this as y. We agree that this length could be anything. We agree that this point could be anywhere. That means if we can prove for this x and this y, it is true for all x and all y. Now let's make a square out of this. Take this as x and this as y, this as x and this as y, this as x and this as y. Now we will join all these points. We know that all the angles of a square are of measure 90 degree. If we take this right angle triangle, we can see that this triangle is equal to this triangle, or to be more precise, this triangle is congruent to this triangle, that is this original triangle. Since this is x, this is also x, this is y, this is also y, here it is 90, it is also 90. That means this length is equal to this length. Since this length is z, this is also equal to z. Since all these four right angle triangles are congruent to this original triangle, therefore this length is also going to be equal to z, this is also z, and this one also z. Now we know that the sum of all the three angles of a triangle are 180 degree. Since this is 90 degree, therefore this angle plus this angle is equal to 90 degree. If I mark this angle as angle 1 and this angle as angle 2, then angle 1 plus angle 2 is equal to 90 degree. We know that all these four triangles are congruent to this original triangle. Since this is 90, right? I name this angle as 1. That means this angle is also going to be equal to 1 using the concept of congruence. This angle is 2. That means this angle is also equal to angle 2. This angle is also going to be equal to 1, and this angle is also going to be equal to angle 2. Now since this is a line, and here at this point the sum of all these three angles is going to be equal to 180. But we know that angle 1 plus angle 2 is equal to 90 degree. That means this angle, that is the middle angle, is going to be equal to 90 degree. In the similar manner, all these angles are a measure of 90 degree. Therefore, we can conclude that this quadrilateral is nothing but actually a square. Now, we will calculate the area of this square. The area of this square is equal to x plus y whole square. That is also equal to the area of these four right angle plus the area of this square. It is 4 times area of the right angle triangle, that is 1 by 2 base into height, that is x into y, plus the area of this square, that is equal to z square. We know that x plus y whole square is equal to x square plus 2xy plus y square. On simplifying this, it will be equal to 2xy plus z square. Upon cancelling 2xy and 2xy, we get x square plus y square is equal to z square, which is Pythagorean theorem. There are many applications of Pythagorean theorem in everyday life. Like it is used in 2D navigation. It is also used in painting the structures, architecture, construction and design, and many more fields. I hope you have enjoyed this video. Thank you so much.